Let's take a look at the tangent graph, and then we're going to graph a few of these that have transformations applied to them. So the tangent graph is computed by saying sine of x over cosine of x. It's a periodic function, so it repeats over and over again to the right and to the left with different angles. We tend to focus on one period of this graph, so it goes in between negative pi over 2, where we get a vertical asymptote, and positive pi over 2. The other key points we want to include on this are typically it's at the origin, this middle point in between negative pi over 2 and positive pi over 2. The other key point tends to be at negative pi over 4, corresponds with negative 1, and positive pi over 4 corresponds with positive 1. We want to include those as to indicate any stretching factors or compressions that are going on with our graph. So let's jump right in and talk through a couple quick examples on how to sketch the graph for one period of this function where we have negative 0.5, a multiple attached to the entire function, so that's going to affect our y-axis, and then this pi over 2 multiplied by x on the inside. When you have a number attached directly to x, that's going to affect the x-axis, or a left and right kind of movement. So as we take a look at this, I'm going to go ahead and label my y-axis. I need to include these key values of 0.5 and negative 0.5. Now this has not been shifted left or right. We don't have a phase shift attached directly to the x on the inside here, and it hasn't been shifted up or down because we don't have an addition or subtraction attached to the entire function. The only other thing that we have to be careful about is this pi over 2 on the inside. What that's going to do is that's going to affect our period. So we could calculate our period very similarly to how we do in sine and cosine. We start with the original period, but it's different for tangent than it is for sine and cosine, that the original period for tangent is just pi instead of 2 pi like it would be for sine and cosine. Then what you want to do is you want to divide by this multiple that's on the inside. So pi divided by pi over 2, which can simplify down as pi, copying down the numerator, multiplied by the reciprocal. So multiplying by 2 over pi is going to produce a period of 2. As these pi's get to cancel out when you're multiplying and dividing by the same thing, that creates a 1. So what that kind of tells me is the entire period here is going to go from negative 1 to positive 1. What you want to remember as you're doing this is that period goes all the way from the left to the right-hand side. So half of it's on the left-hand side, and I'll label this as negative 1. And half of it goes on the right-hand side, so I should put a positive 1 over on the right-hand side. The other thing to note is those key points. We're going to get 1 here and 1 here. Now this is halfway in between the origin and this vertical asymptote. So in our case, that's going to be a negative 1/2, and at positive 1/2 on the right-hand side between 0 and the vertical asymptote that's at 1. So I'm going to try to label things as we go. Now this one has not been flipped upside down. We don't have a vertical reflection because we don't have a negative in front. So that means it's going to be increasing the entire way. So I'll kind of put these key points in here. We'll also get one at the origin. And then to graph this, we know we have to either go up or go down when we get close to these vertical asymptotes. So in this case, it's going to go down to the left and up to the right. Make sure you label these key points as we go along, and we should be good to go. All right, let's try one more where we have 3 multiplied by the tangent of pi over 6. Again, pretty similar as far as our transformations go, that the 3 is going to be a label on our y-axis. So positive 3 and negative 3. Again, this hasn't been moved vertically, and it hasn't been shifted with a phase shift left or right. So the other thing to kind of calculate here is the period. The period in this case is going to be pi divided by pi over 6, or equivalently pi times 6 over pi, which is going to result in 6 being our period. So what that tells us is this is equally distanced left and right of the origin. So it's going to go from negative 3 to positive 3 based on this period being 6. Half of it's on the left, half of it's on the right. That's where our vertical asymptotes are going to be located. So I'll go ahead and sketch those in. The last things we need to do are get these other key values on our x-axis. So halfway between 0 and 3, we should get 1.5 right here, 1.5. And then halfway on the left-hand side, we get negative 1.5. All right, we'll go ahead and put our key points in. Again, this has not been inverted. It hasn't been reflected vertically because this is not negative out in front. So it's going to be increasing the entire way. So kind of place our key points there at positive 1.5 and negative 1.5, as well as the origin. And then this will be increasing the entire way. So kind of takes on that look. Again, when you get to the vertical asymptotes, you're going to go up on the right-hand side and left on the left-hand side, as this has not been flipped upside down. All right, hope this helps out as we're trying to label our x and y axes and get really good graphs of tangent functions. Good luck.